Hello and welcome to this Reigate College video on successive collisions. This is an important example because often really quite long questions on this topic come up in the mechanics section of the examination. So it's really worthwhile getting your head around exactly what you've got to do. So if we're going to start by looking at horizontal collisions. If we've got more than one collision happening, so this tends to happen when you have, for instance, a series of particles like this, and these two are, so maybe this is projected with a speed of 6, this one's already moving with a speed of 2, and this last one is stationary, then what happens next? So this one is going to hit this one, and then depending on the masses, this one will certainly move on and hit this one, but this one might go backwards or it might carry on in this direction. And we have to investigate what's going to happen. So there's nothing new in terms of the mathematics. You've just got to organise your thoughts very carefully. So we're going to look first of all at this question here. We've got three spheres, A, B and C, with masses m, 3m and 4m respectively. So this takes quite a bit of space, and just in order to be clear, I'm going to set it out on some separate paper here. So first of all, just get your head around exactly what's happening. Three spheres, A, B and C, have masses m, 3m and 4m, and the spheres are moving in a straight horizontal line with A following B following C. Initially, the speeds are 8, 4 and 2. A collides with B, and then B collides with C, and the coefficient between A and B is 0.6, but the coefficient between B and C is 0.3. So we've got a lot of information in this paragraph here. Double check that you've correctly moved it to your question, your diagram. So the best thing to do is take each collision in turn and work very clearly and methodically through this. So if we take the first collision between A and B, we've got this situation here. So this one is moving with 8, this one with 4, and I'm going to call these V1 and V2. You could call them VA and VB, but we're then going to have extra, V is going to have different velocities after it collides the second time. So that's why I would label it V1 and V2. Just for sort of added insurance, I might put in here A and B, so that I'm just really clear afterwards what my V1 and V2 stand for. So we start off with the principle of conservation of momentum. So the equation we're going to write from here is 8m plus 12m is equal to m multiplied by v1 plus 3m multiplied by v2. So that simplifies to 20 is equal to v1 plus 3v2. And that's going to be equation 1. Newton's law of restitution says E, which is 0.6 for this pair of collisions, is the separation speed, which is v2 minus v1, over the approach speed, and the approach speed here is 8 minus 4, which is 4. So that gives me V2 minus V1 is equal to 2.4, and that's equation 2. We're going to solve these equations by adding them together. So if we add them together, we get that 4V2 is equal to 22.4, and that gives me V2 is 5.6 and V1 is 3.2. So we now know the speed of A and B after the first collision. We now need to look at what happens for the next collision. So the next collision is going to be the collision between B and C. So we now know that B is moving with the speed V2 from up here, and V2 was 5.6, so we can write that in here. V2 is moving with 5.6. C is moving with the 2 that we were told at the beginning of the question. So this is B, and this is C, this is B, and this is C. And we're now going to call these V3 and V4. We don't know what direction they're going to go in. It's just possible that this one rebounds. But if we move them this way, if V3 is negative, we'll know it's coming back that way. So again, we're going to do the conservation of momentum. So I've got 3m multiplied by 5.6 plus 8m is equal to 3m v3 plus 4m v4. So that gives me my first equation. And once you tidy up the numbers for that, that gives you 24.8 equals 3v3 plus 4v4. We're going to do Newton's law of restitution here. So that says that E, which in this collision is 0.3, just be careful there, is separation, which is v4 minus v3 over the approach speed, which is 3.6. So this gives me the equation v4 minus v3 is 1.08. I'm going to call this equation here 3 and this equation here 4, and we're going to solve those two equations simultaneously. Now, when we do that, you actually end up with the following answers. You get that v3 is 2.926 and v4 is 4.0057. I have to say that this is slightly unusual. These answers normally come out to be not necessarily whole numbers, but not usually decimals like that. So, you know, that is a slightly unusual feature of this question. Right, so now we need, so we found now the velocities, what was the question? The velocity of the three spheres after the second collision. So after the second collision, let's just be absolutely clear with our answer here. What's happening to each of them? So A, after the second collision, so the first collision is A and B colliding, and then the second collision is B and C colliding. So after the first collision, A is moving with the speed of V1, which is 3.2. So that's A. B is moving with a speed of V3, which is 2.926. And C is moving with a speed of 5.0057. So it says, show that there will be another collision. So this is the position after two collisions. And you should be able to see that because this velocity here is greater than this one here, A and B will collide. A will catch B up. So you would write that the velocity of A, which is 3.2, is greater than 2.926, which is the velocity of B. So there will be a third collision. And we've showed that there'll be an extra collision here. Be careful here. If these came out to be exactly the same number, there would not be another collision because they would be moving, they would be slightly apart, and they would be moving together with the same speed. So then there wouldn't be a collision. So you do need to pay attention to your inequality signs here. If B had ended up coming back this way, then that's clear that there is going to be another collision, provided that A is moving in that direction. So you have to consider each pair of collisions. These questions can be quite complicated, so it's well worth taking the time to set your work out extremely carefully.